D&D Manufacturing is a 14-year-old company with a history of solving complex problems. One of the problems facing our society is finding a sustainable way to reduce greenhouse emissions from heating our homes and buildings. Another problem is to find suitable uses for our waste plastic stream. D&D has designed and built an efficient and cost-effective solar collector to heat buildings and homes using 100% recycled HDPE plastic. As can be seen from the diagram, cooler air is flowed through the panel, allowing passive solar heating of the air. This design allows for a very efficient heat transfer with relatively low pressure drop through the panel. An integrated solar greenhouse shield significantly increases the solar radiation absorption. The initial testing of this panel was done on a small test building with very encouraging results, as some inlet to outlet temperature deltas were as high as 46 degrees Fahrenheit at 330 CFM. A panel was tested in Vancouver, Canada to understand efficiency in higher latitudes during the winter months. The panel was tested in both high and low light conditions. Unfortunately, due to COVID pandemic restrictions, D&D was unable to have access to the homes and buildings it had chose to test the solar AirWall on for the next phase of testing. Instead, D&D rented a commercial building to install, further test, and improve its solar AirWall. As can be seen in this photo of the installation, the inlet was installed in the ceiling of a room and the exit in the same room. A variable speed fan was installed in the attic to pull air in from the ceiling through the solar panel mounted to the outside of the building on the south side. The heated air was then returned to the building through the wall baseboard. As expected, the highest thermal output occurred in the early afternoon hours with a steady solar 82 degree Fahrenheit ambient temperature, input radiance above 200 BTUs per hour per square foot. The black surface of the panel reached 160 degrees Fahrenheit. The outlet temperature was steady at 142 degrees at 300 cubic feet per minute. To understand if the D&D solar panel could be used in a complete 100% passive manner, the air-blowing apparatus was taken off from the inlet and the panel retested. As expected, there was some chimney effect as the hot air in the panel expanded and rose. However, with the high solar radiance above 200 BTUs per square foot per hour, did any significant airflow occur less than 50 cubic feet per minute. It is the conclusion of D&D that a small PV-powered fan driving the unit is the best option. Next generation unit. The current design is two identical panels put together with the outside-facing panel having the clear greenhouse shield. D&D then tested the concept of using only the outside-facing panel with the greenhouse shield and use of off-the-shelf foam board as the backing. This arrangement was reinstalled on the building and tested. The results between the two-panel and one-panel scheme were within statistical limits. A future step is to build a mold capable of producing two panels at once with these possible modifications. Increase the height of the panel for one-panel use. Install a water escape on the panel. Investigate use of heat transfer additives to the HDPE to improve heat transfer. Investigate if we increase panel efficiency by adding or deepening the surface features, thus increasing the surface area of the panel. These last two items will allow us to understand if heat transfer efficiency in this application is convection limited, that is, design surface area dependent, or conduction limited material dependent. Is it possible to use the panel as an air conditioner in the summer months? The D&D Solar AirWall is two separate devices in one. It is a very efficient solar energy collector with its greenhouse shield with a solar collection efficiency of over 60%. The panel is also a very efficient heat transfer device even at a low temperature deltas. The greenhouse shield was removed and the panel tested not as a building heater but as a building cooler. On the night of February 19, 2021, the outside air was 59 degrees Fahrenheit and the inside building temperature was 84 degrees Fahrenheit. The panel was tested with a 300 CFM flow. The return air was a steady 62 degrees Fahrenheit. The panel could easily replace the attic cooling fans used in some houses to cool the home at night and lower the thermal mass of the home, thus reducing the thermal load required by the home air conditioning units during the day. Now meet the D&D team. Dale Polk, the inventor of the STF plastic process which produced the panels. Carl Polk, the CAD designer who perfected the solar AirWall's airflow scheme. And Nicholas Probert, marketing and sales director for LIT.